Greetings, 7th grade. Today, we are actually talking about multi-step equations. Because AMEG doesn't just help you to solve two-step equations, she tells you how to solve any equation that has as many steps as you could possibly want. So, please put your name at the top, date as well, and this title, because guess what? We're hanging out with AMEG again. So here we go. Let's talk about why AMEG is so good at what she does. Well, let's look at a problem that AMEG is really good at. In this case, we have two x's, two x boxes, 2x plus 3. We have 3 more that are with it, and it's equal to 12. Now, if I was trying to solve this equation, I'm trying to find out what's in one of these x boxes. Now, to get that x box alone or isolated, I would need to get rid of these 3 and get rid of the other x box. We talked in the past that to undo multiplication, you can split into groups. Undo addition, you can subtract. Now, what's going to be the easiest way to undo this? It's probably just going to be to get rid of these 3 first. And I'll show you why. If I just get rid of 3, I can get rid of 3 on either side. But if I try and split it into groups and undo multiplication first, then I can make each group have an x and 1. But then this last guy kind of gets hanging out to dry. Now, sure, you could say, Mr. Schwartz, just split it in half and you have x plus 1.5. Brilliant, you're right. But then you would have to subtract 1.5 from both sides, and most people don't like to deal with decimals or fractions until the end unless they have to, and we don't have to. So AMEG is going to tell us that it's usually easier just to undo addition and subtraction first, and she's right. Another reason that AMEG is so good at what she does is because Gemma tells us not about solving equations, but about combining values. So Gemma tells us, how do you put numbers together? If you have 5 squared plus 3 times 2, what does that equal to? Gemma tells you exactly what to do. But AMEG is saying, if you don't know one of those values and you have to isolate it, you have to undo what's been done. And we want to follow the opposite of the order of operations. We want to undo all of that. We have to kind of go backwards to get one of those numbers alone, one of those values alone. So people love to talk, oh, I love hanging out with Gemma and AMEG, so funny. The idea of Mr. Schwartz could never ever have a girlfriend, ha ha ha. But if you remember Gemma and AMEG, but you don't know who's so good at what type of math, then you're a fool. And you make them and me sad. So remember, Gemma is good at putting numbers and values together. AMEG is good at undoing things like relationships and solving equations. 2 other notes. Once you isolate a grouping symbol, like AMEG is going to say to leave grouping symbols as the last thing that we're going to undo. But let's say that you isolate a grouping symbol and it says x squared plus 5. We'll continue to follow AMEG and undo addition first and then undo exponents last. It's kind of like Inception. And then for the last one, we're talking about square rooting and squaring this year a decent amount, and you guys have gotten pretty good at that. So know that I can ask you equations involving squaring and square rooting. And square rooting undoes squaring, and squaring undoes square rooting, vice versa. They undo each other. We call these inverse operations. So let's get to some notes. Not some notes. Let's get to some examples, and I'm going to recreate that first example we saw at the beginning of the video. You did not have to copy it down then, but you do have to copy it down now, along with the picture, please. First, let's just say, what do we have here? We have 2x, we're going to add 3, and then the scales of justice are going to tell us it's equal or balances with 12. They're equal values. AMEG is going to say undo addition and subtraction first. So if I subtract 3 from both sides, that's okay because those are equal operations. And these are inverse operations. They undo each other, they cancel out, and we're just going to be left with 2x is equal to 9. Final step would be to undo multiplication by dividing both sides by 2. And if we do that, we're going to have x is equal to 9 halves. That's 4 and 1/2, or 4.5. 1/2 is 0.5 in decimal form. Now let's see what it would look like in picture form. Well, again, we said it's really easy just to get rid of 3 tiles on both sides. So let's do that. And that's kind of what we represented right here. They should stay balanced because we took the same amount off of both sides. Next is to split it into 2 groups. And if we do that, we kind of run into that same problem I mentioned earlier. Well, we had this one extra guy who's hanging out to dry. But when we take away half the values, at least now we just have our answer includes that decimal. We don't have to do any operations with that decimal. So Meg, she knows what she's talking about. Hopefully you have this drawn and also the work that I just erased written out. No, where'd I go? I'll get back in a minute. Okay. I'm back, baby. Here we go. Now let's move forward. We have, for example, number 2, 3 times the quantity of m minus 13, or 3 times the difference of a number and 13, is 75. We talked about writing equations earlier, so that would be a great way to write that one. If you're like me, you're looking at this and you say, ooh, we have a number right on the outside of a difference or a sum. That always tells me that I'm allowed to do the distributive property. So we're going to solve this with the distributive property first. Remember that we can either find the difference because it's grouped and then multiply by 3, or we can multiply the two different parts by 3 individually. So 3 times m and 3 times 13 would be 39. Now this looks a little different, a little easier. We don't have any grouping symbol to worry about. We can just say, draw the scales of justice. Locate the variable, it's m. It's been multiplied and had something subtracted. Gemma says undo. Oh! Meg says undo addition and subtraction first. So we'll undo subtraction of 39 by adding 39. If 3m is equal to 114, we could divide both sides by 3 to undo multiplication with division. Those are called inverse operations. Say it with me, inverse operations. And m is going to be equal to 38. Now, let's say you didn't see the distributive property. I'm going to expect you to write these both ways in your notes, by the way. If you didn't see the distributive property, you could still solve it by following a Meg. She's just that good. You would say 3 times the difference of m and 13 is equal to 75. Well, a Meg says undo grouping symbols last. So m minus 13 is in grouping symbol, so we'll leave that for the end. Instead, let's undo multiplication by 3 first. Divide both sides by 3. And you have just m minus 13. Hopefully you know that 75 is like 75 cents. 3 coins would each be quarters. And now we can just undo addition by adding 13. Guess what we're going to get? Same answer. A Meg steered us clear. We get 38. So whether you do the distributive property first or not, it's up to you, but I would like you to start seeing this. You really need to start picking this out. It's going to be super helpful to see that 3 times the quantity of m minus 13, you can do distributive property whenever you have a number multiplying a sum or a difference. Let's move on to number 3. G squared plus 17 equals 81. A Meg, or well, our steps say, draw the scales of justice. Step number 2, find the variable, Jace. Our variable is g, and what's been done to g? It's been squared and it's been added. Omega is going to say undo addition before you undo exponents. So let's undo addition by subtraction. The inverse operation of addition is subtraction. And we'll have g squared is equal to 64. Oh. Well, if g squared is equal to 64, how do I undo squaring? What did that note say? Oh yeah, it said square rooting undo squaring. So I draw it through the square symbol, the two exponents, so I know that they cancel out. We'll just have g left. What's the square root of 64? Positive or negative 8. So g could be 2 different answers. This equation has 2 answers. How exciting. Okay, hopefully you have all those down. As always, I'm going to leave you with some problems to do on your own. Here they are. 2m minus 37 equals negative 55. And number 2 is 3 times the quantity of x squared plus 7, all equals 96. Best of luck on that last one. A multi-step equation. If I've ever seen one, I'll see you guys later.